We live on a very unique planet, Earth. Have you ever wondered what it's made of, what lies beneath our feet? Let's explore the different layers of Earth, from the crust to the mantle and core, and uncover one of nature's greatest mysteries. Masoni overview of Earth's structure. Earth is divided into three major concentric layers: the crust, mantle, and core. These layers differ in their composition and physical properties. Seismic studies have helped us understand how seismic waves travel through these layers, allowing us to map out the structure of Earth. We will start by looking at the Earth's crust, the outermost layer of our planet. 1. Earth's crust. Illustration of Earth's crust. The Earth's crust is the thinnest layer surrounding the entire planet. Its thickness varies, ranging from 5 to 10 kilometers beneath the oceans to 30 to 40 kilometers in the continents, and up to 75 kilometers in high mountain ranges like the Himalayas. The speed of seismic waves, VT, in the crust ranges from 6.5 kilometers to 7.4 kilometers. But when these waves travel into the mantle, they suddenly increase, reaching up to 8.2 kilometers. This sharp change marks the boundary between the crust and the mantle, which is called the Mohorovičić discontinuity, or simply the MOHO. 2. Mantle. Illustration of the mantle's structure. Below the crust lies the mantle, which extends from 30 kilometers to 2,900 kilometers deep. The mantle is divided into two parts: the upper mantle and the lower mantle. In the upper mantle, there is a layer called the asthenosphere, where seismic wave speeds decrease significantly. The asthenosphere is crucial for tectonic plate movement, which leads to phenomena such as earthquakes and volcanic eruptions. Seismic wave speeds in this zone drop below 7 kilometers and only begin to increase again as we go deeper, past 250 kilometers. Notably, around 100 to 150 kilometer depth, the seismic wave speeds drop sharply, creating a distinct boundary between different layers of the mantle. This zone plays a critical role in the tectonic activities of Earth. 3. Earth's core. Illustration of Earth's core. Beneath the mantle is Earth's core, which extends from 2,900 kilometers deep to the center of the Earth at 6,370 kilometers. The core is divided into three layers: the outer core, the transition layer, and the inner core. The outer core, from 2,900 kilometers to 4,980 kilometers, is composed of liquid iron and nickel. Seismic waves passing through here slow down, and S waves, shear waves, disappear entirely, indicating that this layer is in liquid form. From 4,980 kilometers to 5,120 kilometers, we have the transition layer, where seismic wave speeds suddenly change. Finally, the inner core, from 5,120 to 6,370 kilometers, is solid, composed primarily of iron and nickel, and subjected to extremely high temperature and pressure. Asthenosphere and its role in tectonic activity. Illustration of the asthenosphere and tectonic plate movement. The asthenosphere, located in the upper mantle, is a ductile zone that allows the Earth's tectonic plates to move. This movement leads to earthquakes, volcanic activity, and long-term geological changes. Its ductile nature is critical for the Earth's tectonic activities, leading to the formation of continents, mountain ranges, and other geological systems. This table illustrates the division of Earth's layers, detailing the depth, seismic wave velocity, V's, density, and pressure at various points within Earth. The data shows the different characteristics of each layer, providing insights into the material composition and physical processes that occur beneath the surface of our planet. At final words, Earth is a remarkably complex and dynamic planet. From the crust to the mantle to the core, each layer has unique properties that contribute to the planet's ever-changing landscape. Thanks for joining me on this journey through Earth's internal structure. This English version of the script provides a clear, structured presentation of Earth's layers, including the table for a more in-depth understanding. Let me know if you need any further adjustments.